In this video, we are going to discuss example 6.1, weightlifting. The problem says, let's consider the gravitational potential energy in a specific situation. A weightlifter lifting a barbell of mass m. What is the gravitational potential energy and the work done during the different phases of lifting the barbell? Question has given us different phases of lifting a barbell, and they want you to find what is the gravitational potential energy and the work done in each of the phases from A to D. Let us define the gravitational potential energy and work. Gravitational potential energy UG is given as mgy, whereas the work done can be written as mgh. This potential energy depends only on the position y along the y-axis, whereas the work done is dependent on how much you move, the change in position along the y-axis. So if I take an example of a box being lifted from a height h1 from ground to a height h2. If I were to find the work done in moving the box from h1 to h2, I write my work to be numerically equal to mg h2 minus h1. Because we are only looking for how much work the force has to do in order to move the box from position h1 to h2. But if I want to find potential energy of the box at h2, I write potential energy UG as mgh2. The value of potential energy only depends on the position of the object and not the initial point. So if I were to find potential energy at h1, I will write as mgh1. And if I were to find potential energy at h2, I write it as mgh2. Whereas for work done depends on the position, the initial and final position. And when you're moving from one point to another, you take the difference in height from between those 2 points. So let's apply this while solving our problem. In part A of our problem, the object is at the reference point. Reference point is the point where we take potential energy of the object to be 0, where your height over which the object is raised is 0. So in part A, since my object is at the reference point, my y position is 0 or my height is 0. So potential energy of the object will also be 0, as well as the work done will be 0. Next, go to part B. In part B, my object is raised at a height of h by 2. So potential energy of the object will just be mgy. And since we are raised at a height of h by 2, I will write this as mg h by 2. Work done, on the other hand, when we are calculating the work done by the gravitational force will be negative mgh by 2. Why negative? Because force due to gravity acts vertically down, whereas displacement of the barbell in this example is up. Whenever force and displacement are opposite in direction, work done by that force is taken as negative. So when we write for work done as mgh, we take this work as negative whenever force due to gravity and the displacement are opposite in direction. Then we come to part C. In part C, the object is moving from a position h by 2, I will call this position 1, to a position h, I will call this 2. When I find potential energy is just dependent on the position mgy, And my final position of the barbell here is H. So I will just substitute for Y as H. Potential energy will be mgh. Work, on the other hand, will be written as negative mg h2 minus h1. Because when we are calculating work, we are determining how much work the force does when the object is moved from position 1 to position 2. And here my position 1 is h by 2, position 2 is h. The negative sign because again at this position, force due to gravity and the displacement of the object are in opposite direction. So we substitute here negative mg, h2 is h, h1 is h by 2, and we get work done due to gravity to be negative mg h by 2. The last part, here the object is brought back down to the reference point. So since at the reference point my position along y-axis is 0, potential energy at this point will be 0 because y is equal to 0. Work done on the other hand will be mgh. Why mgh? Because initially you were at this position here, h. You moved from h to 0. So you need to find how much work you did when you moved from h to 0, which will be F times d. F is m into g and d is the height covered, which is h. And we take this work to be positive because in this case, both my force due to gravity and the displacement of the object h are in the same direction. And whenever force and displacement are in the same direction, work done by the object is positive. So these are the values of potential energy and work done while describing the different phases of barbell.